All right, let's try the last bit of Splunk, which is a bit bigger. This is, I'll make this wider. There we go. This part here, a ransomware attack. So we want to find the IP address of this desktop machine, which is going to be the source of the infection. So we're going to search for the name of it and find 181,000 events. And then we're going to look at the source field and try to choose a stream source that is associated with IP addresses. So we look at the source field and we see there's an LDAP stream, and I think that's what we want. LDAP is used in Active Directory logins. And now we have 74 events. And we want to find events on that day. So I'm looking for 24 August 2016. So I'm going to go here and go down to date and time range. Okay, I want to do between 24 August 2016, okay? August is 8. 24, 2016. And 8/25, that might do it. I think I want 0 here. Let's see if that works. All right, I've got 48 events. And look at their IP addresses. Destination IP. I imagine that's probably the domain controller. And source IP. This would probably be that machine's address. I think that's how it works. So these are LDAP events. So I think that is the IP address. And let me save that where I'm saving useful facts. This is the IP of the desktop computer we're interested in. All right. Now I want to find the malware. There was a ransomware attack server detected by Suricata. So search for this. And then again, limit the sources. So we'll start just by looking for server. And I want to go back. Do I want to be on just that day? I think we want to be all time. Yeah. All right. All time again. All right. All right. And now we look at the source of these. And we want Suricata. I'm thinking this is probably it. There are 5 events. A network Trojan was detected. Suricata under domain look. Okay, onion domain lookup. So these are Suricata events detecting server. And all right, you want to find which one alerted the least number of times. So we look at the signature ID. There's Suricata signature ID. And there you go. There's one that alerted only once and the others. So that's how you can find the Suricata ID. And now we want to find the domain name that it connected to. Unfortunately, which is pretty rude. See, when ransomware infects you, first it downloads some script or some exe file, which does the infection, does the encryption, and then it pops up a ransomware note, and it loads that from a Tor domain typically. So it's an onion domain lookup is what this picked up. And it might look like you're getting there with this event right here, a network Trojan onion domain lookup, But unfortunately, for some reason, Suricata does not give you that onion domain, which is sort of rude. In fact, it's kind of hard to find. So here's the process I like best. Find the Suricata alerts about onion domain lookup, restrict the time to within 1 second of that, and then look for DNS events. And so here's the onion domain lookup. And I think I was able to use the mouse here. If I click on this, I can now make it plus or minus 1 second from that and apply that. This is a much more easy than going through that time thing up here. A much more easy way to narrow in on a certain range of events. And now I want to look at DNS events in that range, stream DNS events. So I'll go here and I'll remove these criteria. So I'll get all the events in that time range. Well, all right, maybe it's not going to let me do it. It's source equals stream. I think I'll just type it in, source equals stream DNS. All right, let's see if this works. There we go. I have 16 events. And I'm looking for the fully qualified domain name that it connects to. So these are DNS events, and somewhere in here should be the domain name. If I, up here, host name. Okay, that's the server, I think. Here's the name. All right. See what we got here. It should be query, I think. DNS, let's look at the query. Oh, there we go. So these are Microsoft and Bing. This is it. This one is just server something. That's the domain name it used. All right. That's the thing that actually resolves somehow to an onion domain. I'm used to seeing them end in .onion, but this is an onion domain in another format. All right. And so now we want to try to figure out how this person got infected. So what was the first suspicious domain they examined that this website went to on 24 August 2016? So I want to look at Suricata events on that day. So I'll go back here, 24 August. Looks like now I'm restricted to a certain number of seconds on that day, but I want to go back to covering the whole day. So I'll do from 000000.000 to 23:59, 59 seconds. There, I got a 59 though. That should be pretty much the whole day. And, okay. Find Suricata events on that day. So not stream, but Suricata. So let's get rid of this. I'll just make it source equals star for right now. And then I can get a list of possible sources here to choose from. And come on. Still searching and changing. So, all right, source. And there's Suricata. All right. And 15,000, 23,000. I should find 86,000 of them. Yep, okay, 86,579 of them. Now look at the source IP field. Okay. And I'm trying to find things that came from the desktop. So I remember the IP was this one, 250.100. All right. So that'll be the events from the desktop and Suricata. Now look at event type and look for things that load web pages. All right. That would be HTTP, not these other things like DNS. I'm down to 38 of them. Good. Now look at the host names, and you can find the one that's malicious. So host names that this person has been going to. HTTP host name. Okay. So again, Microsoft, Bing, Acronis, these all look harmless. This is the goofy one, Solidarity Proximity. And you can verify that this is malicious by just examining it the way we did before in Google. And you'll find this is known to be a domain name used by the server ransomware attack. So it's a malicious domain. All right. Now we can find the VB script. This is how this particular attack worked. It downloads and runs a VB script. So search your events with both a VB script and an exe extension. That's how it runs it. So it's VBS and exe. So let's go up here and get rid of the date time range, go back to all. And then .vbs and .exe. Only 16 events. Let's narrow this down and examine the body field and find the malicious one. So here's the body. Okay, a new process has been created, new process ID and all that. And if you just scroll down, notice there's some obviously malicious stuff here that will appear. There. This junk is obfuscated script. See, it's all just random letters. It's building end sub with a capitalization wrong function, goofy names, and then it's building something by taking characters one by one with ASCII values to construct some command that would be suspicious. This junk is obviously a malicious script in Visual Basic. It's got a random.vbs, and then it's going to do for I in dim RWL function. This junk here is the malware script. So what do we want to know about it? The entire script, prepended by the name of the launching exe, can be found in a field. What is the name of the first function defined? So you can just read this function, this script to find it. You'll find the first function in here. And this is the command line. The command line is cmd.exe, that's the executable, followed by this random.vbs and all this obfuscated VBS script. All right, and then there's a way to get the field length of the particular field containing the script. I don't think I'll go through it, but there's a, now that you've found the right script, it's not too hard to find. And now, we want to know, this all started because Bob Smith, who runs this workstation, plugged in an infected USB stick. That's where it all started. And the USB stick then downloaded this malicious VB script and ran and infected the servers. So we want to find the USB key that person inserted. And so if you look at this page, it'll show you how the Microsoft registry entries are for USB. And the way it works is you get reg binary, and so these things here. And let me zoom in here. All right, that's not making the images bigger. This is all I want to show you is this one. Let me open it in a new tab. And now I should be able, there, I can make it bigger. All right, so here's, let me turn off this beeper. All right, so notice here, it's kind of meaningless junk, except for the friendly name, which is the name you give it, which might be something sensible. So we're looking for this friendly name in a registry entry, and Sysmon makes registry entries into nice friendly events. So I think we can actually just look for friendly name. Give us information about USB sticks that have been inserted. See what that does. Yeah, there's only 2 such events. And so here's the key path going into the USB part, specifying a friendly name. And this is the name of it, Miranda Pry. And this one here is another record for the same one. And this, if you care, comes from the Batman movie. They're following their script here. There was a treacherous person named Miranda Tate. And so the idea is they tricked this Bob Smith guy into inserting a USB stick, and that infected the company. All right, and so now Bob's workstation connects to a file server during the ransomware outbreak. So he's connecting with SMB to a file share, and the files he can access on the share get encrypted. So SMB stream data for his workstation during the outbreak is what we want to find. So you want source equals SMB stream SMB, Microsoft file sharing, stream colon SMB. All right. And then we want it to restrict it to Bob's workstation. So we might put in the workstation name here, or perhaps the IP address. Let's see what happens if we use the name. The name was we something. There. All right. Might be doing it. And find events with a path by adding path equals star. This means path cannot be empty. If you set it equal to quote star quote, it can be anything, but it cannot be empty. All right, I still have 1,528 of them. And I'm looking for server names. So let's see if we can find server names here. Not Splunk server, but the SMB server, which is going to be path or something like that. Let me see if I left myself a hint. There, path. That's going to be the server. This is going to his desktop, we 8105 desktop. That's Bob IPC. So the path is the thing that shows what the SMB is connecting to. And here it is. Okay. And so because I included Web 185 desk, I'm only seeing events to Bob's machine, it acting as a server. So I've gotten the wrong events here. So I think I need to include Bob's IP address, not his name. And Bob's IP address was this. I saved it earlier. So let's try including that instead. And then see what sort of paths we have now. All right, now we got, okay, so here's the server. And there we are. So now we know the name of the server. So here's Bob's desktop and its administrative shares and the interprocess communication share. And here's the server he's connected to by SMB, because an SMB packet referring to this server with Bob's IP address, and it must be him connecting to it. So there's the name of the server. And of course, files on that server are now going to get encrypted by the malware running on Bob's workstation. So it was connected. We found the IP address of the file server. We could find the name of it here, and we could find out its IP address. And then, all right, search for PDF and restrict your search for the suspicious app. Let's see if that's easy. All right, so we're trying to find the PDFs that got encrypted on the server. So we're going to find events, including PDF. All right, and we're going to find an app field. Here we go. And so these are legitimate Windows processes. I think the suspicious one is the unknown. Find all unique file names. Well, I might be a little confused on this one. App Windows unknown, destination, event type. This is security log. Here's the host, the server. All right. Is there a file name somewhere? Domain, account name, message, a network share object was checked. Okay. Object type file. So there should be a file. Here we are. Relative target name, PDF. Okay, that's what we want, the relative target name. All right. There we go. There's 100 or more of them. Relative target name, I say. There we go. Okay. Now, so we'd like to know them so we can make a list of them. See, sometimes we want unique names. So we can just do pipe and then that relative target name. See if that works. Did I spell it correctly? Relative target name, that looks pretty good, although the T and N should be capital. I don't think that matters, but it might. This should give us a table of them. Yes. Missing or, oh, I think I have to have table. Let me go back to my example of this. We did this earlier. Yep, pipe table. Okay, that's my problem. I need to put the word table here. There we are. Okay, there are 529 of them, but some of them are duplicates. And I think there's a way to make it unique. I think you just put unique here. That's where I think I'm going to Google for it. I forget. It's been a while since I took that certification test. Splunk. Count list unique events in a table. Table command returns a table. This might be the way. Yes. Field renaming, truncated results. Okay. Time, place. Okay, let's see if I can find the word unique here. Yep. All right, how do I do it? Is it a function or something? Okay, unique. The unique command works as a filter on the search results. Pipe unique. Oh, okay. I missed a pipe. Pipe unique. Now I don't seem to be getting any more duplicates. Okay, so now I think I can count them. 100 per page. Yeah, 529 events, but here I only have 342 unique ones. So I think that's a way to get the number of unique files that were encrypted. All right. And you can find the parent process ID of this by searching for the script that was run. I don't think I'll keep doing these. There's a few more things you can find out about this ransomware attack, but it's pretty fun to do this. And you can learn a lot about it. And this is why people pay so much for Splunk. Once you get a little practice, you can hunt through 1 million events and really trace down everything that happens. I'm going to stop this one.